Okay, the last section of this experiment is how to write the result section. The result, the table 3 that I have talked about before, this is the number one result that we have, because this shows us the average RA values and the corresponding system equation values. And this will really tell us what is the lowest surface roughness and what are the corresponding factors and their level. That is what we are looking for in this experiment. However, the three factors that we have chosen, sometimes they interact with each other. How do we know that? In order to find out the interaction, because we are looking at factor A, B and C. Normally it has AB, BC, SC and ABC interaction. The literature is telling us that the ABC interaction between three factors are not very significant. So we are going to concentrate only on two-factor interaction like AB, AC and BC. So how do I construct that interaction? So if you are looking at AB interactions, two-factor, two-level, it can have four combinations. A plus B plus A minus B minus A plus B minus A minus B plus. Only four combinations. I'm going to explain it in the class. So we're going to plot Y average in the ordinate, and A can vary between A minus to A plus. And when A is plus 1, B is plus 1, you plot a point here. When A is plus 1, B is plus 1, you get another point on the right hand side. When A is minus 1, B is minus 1, you get another point. So you get 4 points correspondingly, and you plot this graph. If the two lines do not intersect, it tells us that A and B do not interact with each other, meaning A does not contribute to B or B does not contribute. Similarly, we can take AC interaction, and again A and C, two-factor, two-level, so it can have four values. And we'll have to draw a small table of four values. And so what happens, like before, when A is minus 1 and C is minus 1, we get a value. When A is plus 1, C is minus 1, we get another value. So with these four values, we plot this graph. If these two graphs intersect with each other, it tells us that the factor A and C interact with each other. Is very significant in DOE. We go to C-BC interaction. It is possible you will get graph that will be either one of these two. Either they interact or they don't interact. The way I have drawn it, they don't interact. Okay. So right now we have done an experiment to improve the surface roughness of rapid prototyping samples using designer experiment technique. It's a very advanced, very beautiful technique. There are a lot of jobs for engineers to go out and work on this DOE, but you have to be very, very good at it. I have only used three factors, two-level. In my life, I have used like a four-factor, four-level, but you understand the experiment 4 to the power 4 is a lot of experiment. It's very difficult to do it. Sometimes in DOE, we also use partial DOE, meaning we do not go to full factor, we're using full factorial here. Sometimes you can use partial factorial, meaning rather than 8 experiments, you can do 4 experiments. It's not very ideal, but it can be done. So my students, I'm very happy to expose you to this beautiful technology of designer experiment. And again, we are emphasizing rapid prototyping samples. And I hope that this helps us do quality work in our life. Thank you again. Bye.